function. What's our frequency? Is it negative 14 or just 14? Right? Minus. What function is what?
3 exponential
3
exponential 19. Minus 19. No minus. It's minus 19.
Did I give you minus?
It's not minus.
I give you minus. You gave minus. I saw minus in my mind.
I said minus. So
You said minus.
you did not do it with minus. I are doing with minus. Just punch your calculator. Punch your calculator. It's the same answer. Even with the minus. The same exponential.
Yes. How is that possible? As what?
Punch your calculator. Punch your calculator. It's the same thing. The same thing. What's the answer? 1.42. Joy, which kind of okay, you are using your phone?
Minus 2.99.
You are still in that minus 2.
Exponential 19. That's what I got. Yes. How? That's what I got.
Hello. Hello. Now, if you are using your calculator, do this separately, right? Then write the value down. What's the value when you multiply this by this? Tell me the value. 4.4.
That is 1.422 exponential minus 19.
4.422 exponential. When you multiply Planck constant by your frequency, what will you get? Right? Minus 3, right? Exponential 19. What's your answer? What's the answer? Joules, right? So we agree this is our final answer. You are the one solving, I'm not the one solving. So whatever you say is our final answer, is our final answer because you are the one punching the calculator. Please be careful with your calculation. Don't be anxious because you know the formula. You already know the this and you. You are getting minus 8, while everybody is getting minus 1.4. Do you understand? Let's take the second question. The work function of a metal is 4.65 eV. The work function of a metal. Instead of you spelling work function, right? The W naught is equals to, you already know what it means. W naught of a metal is equals to 4.65 eV. Are we seeing that? And the metal is illuminated. And the metal is illuminated by a radiation of 6.86. The metal is illuminated by the radiation of 6.86 eV. What is the kinetic energy? 6.86 eV. What is the kinetic energy of the 6.86 EV.
I got the value by the what? By the what?
Illuminated by radiation of 6.86 EV. What is the kinetic energy of the ejected electron? Or what is just the kinetic energy? Tell us. Calculate it. Ejected, full stop. Calculate. Don't convert, just don't worry, just solve. Our answer is what? The same thing we did before is what we are doing. You are scared to say your answer, you are just watching it, right? And waiting for somebody to say it. 2.21. What's the unit? Is it joules?
Yes.
Toby say joules. Joy, yours is what? 2.21. Yours is what? You are scared of standing alone. 2.21 what? What's the unit? Your one is EV. EV. This is wrong. This is right. Right? Because if they want you to convert it, they will tell you 1 EV is equals to 1.6 exponential. Because did you multiply before converting it to joules? Did you multiply by 1.6? So if you want to convert it to joules, you say multiply by 1.6 exponential minus 19 joules, and then at the end of the day your answer is going to come out in joules. Is that okay? But in this case, they did not make reference to that. So if they had wanted us to convert it to joules, the question, they would have stated it in the question. Are we together? Did you solve it? Hello, did you solve it? Why? Should I still write it on the board for you to see? Had you write it on the board? Who is saying yes? Be bold enough, you paid for it. Who is saying yes? Should I write it on the board? I've seen the person saying yes. E is what? E is what? What function? Right? And our E is now equals to what? What's our E?
6.86 minus 4.65.
What's the answer? 2.21 EV. You that say I should write it on the board, have you seen it now? Okay, do you understand it now? This is the formula that was used. Right? Let's go to the next question.
Victoria,
the work function of a metal is 8.6 exponential 19 joule. The work function of a metal is 8.6 exponential 19 joule.
Is
8.6
exponential 19 joules. It's minus 19. It's minus 19.
8.6 exponential minus 19
joules. Yes. Calculate the threshold wavelength. That is, calculate lambda naught. The threshold wavelength. Lambda naught. This is what we are looking for in this case. So, which formula do we have that is relating lambda naught with energy? It is sweet. You are looking at your note now, it's sweet. When it's jam time, you will not have opportunity to look at your note and open back and open front. So please, go through this thing and be familiar with them. Is that okay? So the formula is what? HC over lambda. Right? is equal to what? Work function. Hello. You see, the formula that relates them is what? Work function is equal to AC over lambda naught. So can you use this with the parameters you are given? H is constant, C is constant. You are looking for lambda naught. Do you have work function?
Yes, we have.
We have work function, right?
Yes, sir.
Then you are good to go. Do you know the value of C?
Yes, sir.
It's only one person that is saying yes.
Yes.
Do you know the value of C?
Yes, sir.
You know the value of C. C is 3 exponential 8 meter per second. And you already know H, right?
Yes.
And you are being given work function in the question. So substitute. What you do first, make lambda not the subject of the formula.
Okay, sir.
Is that okay?
Yes.
Then after doing that, it becomes easy. You have gotten your answer, but you are waiting for somebody to say it first. 2.3. That is how to answer JAMB question. As you are reading the question, you already know the answer. 2.3. What's the unit? Are you in the class? My brother, I asked you to be sitting at the front too. You say you like sitting at the back. Now you are not following. And I'm not happy you are not following. 2.3. So the same answer. Okay, let's still wait. 2 more confirmation, then we move to the next question. One point.
No. It's 2.3 exponential.
Are you sure? Yes. Show me, let me see it. Yesterday we were solving the class. One boy said the same answer. He said it's a lie. He copied it on the calculator. You can borrow a calculator if you don't have. When coming to lesson, borrow. As you are going back, return. Yeah. When you are coming to the class, borrow a calculator. When you are going back, return it. You need it. Joy, you need a calculator.
I have, but I forgot.
Have you done it? Can we move forward? Nobody is saying yes, so we need to iron it out. Where is it? Are we together? Are we together? Are you looking at the board? Stop talking and watch. Now we say work function is equal to AC all over lambda naught, right? So I say for it to be easier for you, make lambda naught subject of the formula. Right? Now you say work function lambda naught is equal to HC, right? You divide through by work function, right? Lambda naught will be equal to what? AC all over lambda. Now watch, if you are writing the exam, you don't have the time to start looking for subject of the formula before you do your work. You don't have that time. When you are being given something like this, do you know the best thing to do is to interchange it? Are we together? Interchange it. Just wipe this, write lambda naught here, write work function here. Don't need to go far. Do you understand what I just did? Do you understand what I just did? We say work function is equal to AC all over lambda naught. And we want to make lambda naught the subject of the formula. You are writing an exam, you don't have the whole time to yourself to start writing, cross multiply, divide both sides by. You don't have all that time. Right? The simplest thing for you to do in this aspect is to interchange. This one should come here, while this one go. Do you understand now? And this one coming here now, you wipe work function, you write lambda note, then you wipe lambda note, you write work function. Do you understand now? Is that okay? Then if you have the lambda note to be equals to AC all over work function, and we say AC is a constant, right? Planck constant, you say is equals to 6.6 exponential minus 34 multiplied by the speed of light divided by our work function is what? What's the value for the work function? 8.6. So our answer is now what you say. So this is how we arrive at this answer. Those of you that like copying, you don't want to solve, you don't want to press calculator. That is the answer. Copy. Can we move forward now?
Yes,
Now read. Right. Question 4, right? Or is it 3?
4.
Okay. If a light with photon E is equals to 3.8 eV. If a light with photon E, sorry, I attended the village school. I'm teaching you physics. I want to learn English from you. How do we pronounce it? Eh?
You are correct.
It's photon.
Okay, photon.
Photon. Okay, photon. Is 3.8 eV, right? Is incidented on a metal. Is incidented on a metal with work function 4.2 eV. With work function 4.2 eV. 4.2 eV. Calculate the kinetic energy. Let me see, serious student. They say the work function is what? The energy is what? Kinetic energy, KE. Our answer is what? You are getting minus. Is it 0.4 minus 0.4?
3.8 is smaller than.
And what is work function? Who can divide work function for me? Eh? Okay. So the work function is greater than the energy.
Yes.
Is that what's happening there?
Yes.
So will the electron be ejected or emitted? Toby, the work function is greater than the energy. So will there be any ejection of electron from that metal?
When the work function is greater.
Yes. Joy, what's the solution? We are having negative work done here, and we are not okay with it. We don't need that minus unless you can do one magic. That will be a positive answer. I said what? Okay. Okay. Not in this one. Not in this one. Not in this one.
15 EV stuff.
This one now, we're talking about energy level. This one, we're big giving the energy. So you want to go and remove energy from work function. Hello. Hello. Now we say the work function of a metal is the minimum energy, right? That is needed to pull out an electron. Now this energy that is being supplied is not up to the work function, right? So no electron will be emitted. So this calculation you are doing is not possible. Because E ought to be greater than work function, right? Then if E is less than work function, there will be no work done. Electron will not be pulled out. Yes, this question is actually JAMB question. And they say, so. What is the answer? The answer, no, they will not give you value as answer. They can give you value 3.2, 3.4 and tell you they can still add to it. No electron will be emitted. You understand? Just like they will tell you none of the above. Are we together?
Does that mean the energy is accumulated?
Yes, now the energy is just accumulated. It's not enough for it to move. It needs to pass the range of that. It needs to overcome the work function. Number one, before it will attain the kinetic energy needed for it to move out of the metal. And we are looking for the kinetic energy when we have not even gotten enough energy for the work function. So it's not possible. Can we move forward? Any question on that? A light of 15 EV falls on a metal. A light of 15 EV falls on a metal. We should not be doing all this example again. Simple. You already know how to do it. I'm not supposed to be doing it. Let's just, I've started reading it. Let's say it. A light of 15 EV falls on a metal and the electron with the maximum KE and the electron with maximum KE of 2 EV is ejected. Maximum KE of 2 EV is ejected. Calculate the work function. Tell me the answer. Let's go to the next topic. Of 2 EV is ejected. Calculate the work function. Let's go to the next topic. You said one? What's the unit? What's the unit? Tell me your answer. Confirm it. Let's move forward. 13 EV. Are you sure?
Yes.
How did you solve it? What's the formula you use? So E is what? Your E is what? EK is what? This is still JAMB question, I think. Very simple. Well, guys, if you don't know the formula, you can divide, like when we used to do tumbo in objective, when we don't know the formula and anything concerning it, you can divide. You can say 15 divided by 2, it will give you 7.5, right? You see the answer there. You say 15 minus 2, you still see the answer there. You still say 15 times 2, the answer will still be there. So which one are you going to choose? If you don't know the formula, you don't know it. So that's the reason why you need to get yourself acquainted with the formula. Are we together? Can we move forward now? Okay, we are talking about stopping potential. Yes, it's a subtopic still under photoelectric. Ola, tell us something about stopping potential. I know your lesson teacher should have covered all this. Ola, tell us something about stopping potential. Toby, we are looking for how to put English together to wind it to. You read it this morning? Abba, to be able to tell us. Just say something. Who can tell us something about stopping potential? Joy. Do you used to read all these things at the end of this way? I'm supposed to be reading ahead. Okay. The voltage requires to.
Yes, it's the minimum voltage.
Okay.
To stop an electron from getting to the anode.
Anode.
Yes.
What? You are saying anode. You are still.
Yes, I just remember.
You are saying what? See money on the ground. Hey, Jesus. Jesus. Are we together? He has a point. He has a very good one. They are saying from the word stopping potential. You know there's an energy, right? And the energy is trying to do what? To stop. What is this stopping? It's stopping an electron. You understand? Just like he say, from getting to the anode or from going to its expected destination. I'm just using a layman language to explain it for you. Do you understand what we say? That the stopping potential is the energy required, right, to stop an electron. Like now, if we're having an electron here, if you're having an atom and we're having an electron here, this electron needs to move from here to here, right, or go out when it's being emitted. Okay, but the stopping potential now is the energy required to stop this from going out. Now in chemistry, you know that there's a force of attraction, right, between the nucleus and the electron that is holding the electron, not making it to follow. That's the reason why if you're having electron in this axis, right, you're having two here, it's easier to pull this, but it's not easy to pull this. Are we together? It's easier to pull this one that we're having in the valence electron. Sorry, valence shell. Right? This is the valence electron. Right? It's easier to pull this off. But it's not very easy to pull this. Because of the force of attraction that we are having between this and this is greater than this. Do you understand? Are we together? That one is, by the way, it's in chemistry. But now, the stopping potential now is now a barrier, the energy that is needed to stop. Are we together? Let's write. Let's write. The stopping potential is defined as the potential needed to stop any electron as the potential needed to stop any electron from reaching the other side. Yes. Or minimum negative voltage. Or minimum negative voltage applying to the anode to stop photocurrent. To stop photocurrent. Apply to the anode. To stop photo current. Yes, photo current. And it is given by EVS equal to, we're having EK. Where S represents the stopping potential. That's the reason why you're having this S here. Are we together? The S is the stopping potential. The stopping potential? No. No. Yes. Yes. Can't spoil the evening. Okay. You know, all these things we are doing, we are still playing around our formula. The only different thing we are having here is S, right? And where S represents what? You know, EK is still kinetic energy. This is what we have been doing since. And EK is also equals to, you know how to bring out your work function, you know how to bring out your HF and others from your EK, right? So should we still write formula that relate them? Abu should go to question. Let's go to the question direct. What is EK? What is EK? EK is equals to HF minus work function, right? And you know that this is also E, right? Now from here now, we can have our EVS will also equals to what? HF. Do you agree? Minus work function. Do you agree? If EVS is equals to EK and EK is equals to HF minus work function, then EVS is equals to this. Do you agree? That's the reason why we are having this. What's the doubt? What's the doubt? Let me clear your doubt. Let Toby clear your doubt. Toby, you don't want follow Uno road. Follow Uno road. Hold your transport to. Can we move forward? Now, from that place, EVS is equals to HL all over minus work function. Make your VS subject of the formula. Yes, just VS. Remove E. Make VS stopping potential, the voltage. Make VS subject of the formula. Make VS subject of the formula. Mathematics students. He said what? Do we agree? Is that what you got? Wait, what did you did? You didn't solve it. Okay, if you didn't solve it, copy. If you didn't solve it, copy.
You have confidence too much. I will see you one day.
Is he reading?
He wrote VS equals to EQ over E.
I need to do laying of hands for you, Ola. Me and you will need to see after this class. I need to pray for you. Is that okay? If you have not solved it, copy. This is the right this thing. So this is your formula. When you are looking for your VS. This is the formula you use.
Now your E look like Lamba.
Lamba. Where's the E? So this is also equals to EK all over E.
Okay.
Do you agree?
Yes.
Do you agree?
Yes.
Because you are the one that say EK is HF minus work function.
Yes, of course. I don't like stress. That's nice.
Are we together?
No, it was actually correct.
Are we together? Are we together? Is there any person that doesn't understand? Do you understand? If you don't understand, tell me. Let me still explain. Balenciaga. Do you understand? I don't know your name. I'm sorry for calling you that. In the evening class, I know all their names. I know all their names in the evening class. Alright, let's take the question. How many times will I say it? If I want to start knowing your name now, before I know one, two, three. Now work I call you can't do. I go dey cram on her name. God bless you. Okay, the maximum kinetic energy of the photoelectron. That's example 1. The maximum kinetic energy of the photoelectron emitted from a metal surface. Photoelectron. So these students, they are staying outside. No, that's serious. Emitted from a metal surface is 0.34 eV. Are you an engineering? You are going for engineering course? Food science. The way you dress like engineer like this, don't go for science. It's still engineering course. Food science and technology. FST. Is 0.34 EV. If the work function of the metal is 1.8 EV, if the work function of the metal, you can write W naught of the metal, 1.8 EV, calculate the stopping potential. Of the metal is 1.8 EV, calculate the stopping potential. This is that question. Are you sure? Tell me the answer. Joy, tell me the answer. 0.348. Was it this formula you used?
This is stopping potential is just kinetic energy. So there was no need for work function. That's why we're arguing that we started to this exactification with the
Yes.
So we did that. What did you do?
I have solved the question now. You have the formula. Tell yourself the real answer or the wrong answer. What was this value among their options?
Yes. This was that.
So let's see what we are going to get. What's your name? What's your name? Oh, Oluwadamilola. What's the answer? Toby, where are we? Is 0.34. 0.34.
It's not valid. The thing is not valid. That 1.8 is not valid.
1.8.
Yes, it's not valid.
The 1.8 is not valid.
It's not needed.
It's not needed.
Okay.
It is stopping potential is because of kinetic energy.
So you saw me yesterday. Okay.
Stopping potential is because of kinetic energy.
EK is what? EK is what?
EK is 0.34.
What function is equals to what?
1.8.
1.8, right?
Yes, sir.
Okay. E is equals to what? E is equals to what?
They did not give us
1.6 exponential minus 19.
Okay, are we using the constant?
Yes.
Which of the constant?
No, 1.6 times exponential minus 19. No, we are not using.
Did I call constant?
No, now we need E.
No E.
I'll keep quiet. One.
So which formula? What is this? Joy. Which formula? First of all, look for E, right?
So E is 2.14.
Which formula?
That's not what it is. Formula E.
This answer is very correct.
Right?
Is that okay? You did not say. Is I thought you said EV.
Okay, yes.
Voltage. Vote. Okay. Did you solve it? Did you solve it? Those of you that got zero.
This is the question.
Is it not the same question? Okay, that's what we are solving, right? Okay. I just gave you that. HF is equal to what?
You said 1.8. Is it 1.8 or 1.83?
I said 1.8. You want to approximate it. Even if you add it, it's still the same thing. It's not up to 4. It's not up to 4. If VS equals to KE, so VS equals 0.3.
You just do EVS equals to kinetic energy because kinetic energy and you already have kinetic energy.
Now, hello. If you are to use this formula, you know your EK, right? You know your EK, right? E is what? E is what? E is what?
1.6.
Okay, divide it. Divide it. What are we going to have? No, I did not give you the constant, right? But I want you to use it. What are you going to get? Use it. Let me see what you're going to get. The same answer, right? Okay. Now, HF is equals to what? From this question, HF is also equals to E. Don't be confused. Eh? Okay. You say E is equals to what? Work function plus EK, right? And E is equals to HF, right? Can we say HF is equals to work function plus EK?
Yes.
Okay, add the value of this and this. What are we having? 2 point what?
17. Victoria.
2.17, right? So impute that value here. It's still the same thing we are going. Right? What? You don't understand? You don't understand? Are we together? What function is equals to what? 1.8 EV plus 0. Is equals to what?
2.14.
Right? Now, from the formula, I say VS is equals to what?
EK over E. Minus 1 over E.
HF is what?
1.14.
They are still using us to play all around. It's still the same thing. This one will even be longer. You have to use this electron as 1.6.
Why I think is that since that HF minus W naught one function is the same thing as the
EK.
Yes, HF minus
Yes.
it's the same thing as kinetic energy.
Now, this one, this is the reverse of this.
Yes.
Right? And this is already EK, right? And we're having EK all over E. So you go straight. Now hold on, listen carefully. Listen carefully. Are we together? Like now, you were not giving E in the question.
Yes.
Now, if you are having an option that say, what do we have as our that says 0.34, is it EV? EV over E. You understand? E will cancel E. You have 0.34 volts. We have used how many methods now? 3 methods. It's still the same answer you get. Hey, yes, but you are at least you are proven beyond every reasonable doubt that your answer is 0.34.
HF minus all functions like this. Then we now get our answer, like what I do for HF and W naught. Then the answer is now
2.14 minus 1.83 will still give you 0.3.
0.34
EV
divided by E. And the E will cancel
E.
Then the answer will now be 0.34
V. That's the correct answer. Which one? Even if you use E as this, you will still get the same answer.
No.
You get. No. Hold on. If I'm to solve this now, right? Are we together? If I'm to solve this, what I will do, I'll multiply my answer by 1.6 exponential. It will convert this. This will be valid and everything will go.
And we will still get the V.
You will still get the V at 0.34. What's the time? 10:12. We still have time, right? How many minutes more? Enough time.
48.
Okay. At least we are moving very fast, and I love it. We are moving very fast. I think we'll enter another topic from here soon. Now, sorry. Can we take the next question? Have you converted this? Yes, of course. Convert this, then divide by this. You have it. You did not copy first. Did you get it? Did you understand? It's down question. Unless E cancel E. It's just one mark here. It's just 2 marks you are looking for. That's the unit self. That's voltage. Leave it there. You want to cancel the V? You want to cancel the V? You cancel the V, you go and bring it back. Can we take the next question? Or you still copying? What you having on the board? Maybe you are still copying. A light of wavelength 5.0. A light of wavelength 5.0 exponential minus 7 meter. A light of wavelength 5.0 exponential minus 7 meter is incidented on a material is incidented on a material of work function 1.90 EV. A light of wavelength 5.0 exponential minus 7 meter is incidented on a material of wave function. You came late today again. Wave function 1.90 EV. Okay. Of wave function, of work function, sorry, not wave function. A light of wavelength 5.0 exponential minus 7 meter is incidented on a material of work function 1. Not wave function. We have not reached wave function. We are still going to wave function. Don't worry. We'll still go to wave function. It's work function. If I say wave function, I'm saying work function. No. Did you hear what I say? We are not treating wave function. 1.90 EV. Calculate 1. Photon energy. 2. Kinetic energy. First one is the photon energy. Photon energy. The second one is the kinetic energy. Then the third is stopping potential. This is why question. First is photon energy. The second one is kinetic energy. Then the third is stopping potential. This is why standard. This is the essay question, I think. So, what's the answer? Have you got it right? Where did you stop? Let me go back to it. A light of wavelength. Now where you stop. Hey, when people are already telling me the answer. A light of wavelength 5.0 exponential minus 7 meter is incidented on a material of wave function. That wave function, don't write wave function, just write W naught. Of wave function 1.90 EV. Calculate CALC dot calculate 1. Photon energy.
Photon energy is
2. Kinetic energy. Kinetic energy. 3. Stopping potential. Thank you very much. Thank you very much. That's the time you need to solve JAMB question. It isn't JAMB time to solve WAEC question. You can see how serious it is. What's the value again?
39.6 exponential minus 20.
No need for the work function, right?
Somebody should confirm this answer. Somebody should confirm it. 3.9 is still the same thing, right? 3.9 what? 96. Okay. I'm still waiting to confirm. Okay. Okay. With this, we are good to go. Tell me the answer to number 2. Tell me the answer to question number 2. What did I ask you to find? Photon energy. E is equals to HF. Photon energy. E. Those of you that are not solving, E is equals to HF. Photon energy. Photon energy. E is equals to HF. Your H is constant. Where are we? Are you not solving? Break EF down, break it down, break it down, break it down. You said the answer is off. What did you say is off?
What did you get? I got 9.2 exponential.
9.2. Who is saying the same thing? That's what you got. Let me see. 9.2 exponential minus 20. I'm still waiting for confirmation. I'm not stopping, no. Hola. You okay? Don't tell us. Kill us.
I want to calm down. I don't want to rush today.
Hola, are you listening to music?
Yes, sir.
You know if you distract you, and you are coming down.
Can we just say something?
All you use.
Why did you come out? Sir, I want to say that was I don't think they really
Huh?
is there a reason to convert the
What's the unit of work function?
work function? It can be in equal.
What is the unit? What's the unit? That's the first question. What's the unit of work function? What's the unit of energy? What's the unit of work function? What's the unit of kinetic energy? So anyone you want to do for us, you want to give us the electrovolt version.
There are times when we
If you want to give us the EV version,
but there are times when we leave it in
okay. Do it in EV.
Hey George.
No, do your own. Do your own. Leave us to do our own.
Okay, easy.
So that it will be easier for you to find your BS.
What's easy now?
Joy, you can convert this thing back to this Joes. Can convert it to EV. What do? By what? Simple. And you're having EV, you can use it and cancel your E, and you still go.
Okay.
Are we together? Your
0.575.
Joes. Your VS.
The one making it not end.
0. Point what? 0. Point what? You said what?
0.575.
This is wrong. Stopping potential is not supposed to be in joules, it's in volts. You are not following. All of a sudden, is it this question that confuse you? Eh? You cannot just change your unit like that. Oh. You have to go back from where you are coming from and change it. Okay. Joy, what's the number 3? Toby, I'm waiting for you. VS is equal to what? VS is equal to what? This is why question. It's a question.
Yes.
This 10 mark. 0 point what? Eh? Where?
For my view.
For your V.
Yes, sir. I'm getting 1.5.
What did you go for number 2?
For number 2, I got 9.2 exponential minus 20.
9.2 exponential minus 20. I will convert it to joule. Then,
I now divided by E for this time. I
so who is coming to solve this for us? I need a student that will come and solve this for us. US, eh? For 1 and 2, we will do the 3 together.
Now let me do it.
You explain. You explain. Okay. Hold on.
ask me question.
Hello, stop the noise. Stop the noise. Let Ola help us out. Hey, I've erased the first answer. You will still give us the answer. You know, when they were calling answer, they did not call your answer for me. Right? But I know you were getting the correct answer. So help us solve.
In joules, I got 9.2 exponential minus 20. So if in terms of PS, right, no, since I have that in joules, obviously I already multiplied by E. I just divided by 1. Now this one, what are you?
Be explaining what you are doing to them.
Yes, sir.
Hey, you're kidding now.
Oh.
The kinetic energy is
I got it, Joy.
not new, very new, like I said, kinetic energy is to be potential something, right? Let's for me to just
Lecture anonymous. This is what this guy is playing. He's playing Kung Fu.
don't mind him.
And he wants to solve this thing and he brought for us. If you get 0, because you want to play. Eh? Please give him calculator.
Don't be seriously.
Do you want this one? Do you think it's easy to stand and be solving something on the board?
This year, same as 10.
Let him get the answer, then he will explain to us how he got it, right? Don't write it, continue. We don't have all the time. You are the one I'm going to point next to. So it's better you understand it now. Which is this? Which one is that small letter E? This one.
Okay, big letter E. That's the right side.
Don't write small letter E, oh, so that we know we have electron. Hmm?
And who's combating? Like, that's correct. Yes,
To convert this. They are having it in joules, right?
Take this one now.
Don't miss. You like a little.
So when you get it, since your answer is already in EV, just write over E. No need to repeat the value.
Do you understand what you just said? Do you understand what you say? But you try. You solve it on the board for us and explain. Will you solve it on the board and explain? Will you solve it on the board and explain?
Oh, my sister. But there's not.
Why won't they video? What is there? Are they seeing his face? They are just seeing his back. Wait, are you two with number one? Our number one is what? Eh?
Is it that this is equal minus 21 or this is equal 20?
It's not the same with. Is it the same with all we are? Our answer number one was what? Answer number one was what? 3 point. 3.96. Okay. Exponential. Okay. Now explain to them. Let them understand. Hola. Explain to them. Let them understand. I'm waiting. No, I don't have all the time. Okay, this is serious. I want to adopt the airport.
Okay. For number one, we are sorry for
Photon energy.
photon energy. And we know photon energy is given as heat. We can also be given as heat.
Listen. It's your fellow colleague that's explaining.
Photon energy can be given as heat. It can also be given as heat F. And it can also be given as heat C over lambda. So now, we have to use this one because frequency is not given. C is a constant, which is 3.10 to the power 8. Why? And also H is a constant, which is 6.62 exponential minus 34. Then lambda is also a constant.
Lambda is given in the question.
Lambda is given as the wavelength. Wavelength is given. So we have to use the wavelength here, which is 5.2 exponential minus 7. When we did the first, we did this times this. When I did this times this, I got 198.78 exponential minus 27. Which, okay, well, if you do it, you can also still get it. The point can shift. You can also shift and come here. Then this will become 86. You can either get this or what I got at first. So I came down, when I divided it through, I got 397.56 exponential minus 21, which can also be given as 39.75 exponential minus 20, or it can also be given as this. So it's all the same thing. The only thing we only shifted the point and increased the power. You got. So
thank you very much. Can you put your hands together for it? Okay, clap. You know it's you. Now, do you know what Ola is using to do shakara. Do you know what he's using to do shakara?
No.
He's very familiar with the formulas. You understand? Even when you are not given C, when you given C in the question, when you given H, you are giving lambda, but he knows what to do already. You understand? You know H is constant, C is constant, and we are giving lambda in the question, and they ask us to find the photon energy. Right? So from there, he easily substituted the constant and divided it by the wavelength. That was how he arrived at this answer. Are we together?
Yes, sir.
Is there anybody that doesn't understand? If you know you did not understand, tell me, let me go over it again. I should go over it again? Okay. Do you believe that E is equal to HF?
Yes.
F is equal to what? F is equal to what? C over lambda, right? Now, instead of writing this F, substitute this. You have H, this F. Right? This is F, right? Are we together? Okay. This is F. This is C over lambda. F is equal to C over lambda. H is constant. F is constant. What is Planck constant? 6.6 exponential minus 34 joules. And what is C? The speed of light or the velocity is 3 exponential 8 meter per second. You understand? You are being given wavelength in the question. 5.0 exponential 7. You divide through. When you divide through, this is what you are going to get. And then you need to be familiar with standard point. Go and study your standard word. What else you call it? Standard form. Go and study it. How to move points from one point to another. They are having 0.00001. How do you write it in exponential form? You understand? If you know all those, you can know how to play around this. They are having 397.56 exponential 21. And you see, in this place now, he wrote 20. He moved it.
I still need to be moved again.
If you want to move on, you can move on yourself. Move and come. If you move it, you will know that as you are moving it, this one is reducing.
Yes.
As you are moving it, this is reducing.
Yes.
Is that okay? So, second question says what? Find the kinetic energy. Who come and help us find the kinetic energy? Can I wipe this? Are you sure? Somebody said I should not wipe it. Who can help us find the kinetic energy? Can I wipe the first line?
Yes.
Second line?
Yes, you can wipe it.
If you know you are not catching it fast, be writing so that when you go home, you still go by. Want to do number 2 for us? Thank you. At least Ola has done, you do yours. So that the guys will know, you can carry your book if you wish. You can carry your book. Carry your calculator. Anything you want to carry, carry. You want to even carry assistant, you can carry. Easy. Stop distracting her. Miss Leader, should be a lady's name, like Mrs. Leader or?
No. Einstein.
You said what? Yes, just solve. And then after solving, you explain. If that's okay. Are you through with this? Can we wipe this? Okay, thank you very much. Bring, let me help you wipe it. You can be writing from up. You are the teacher and I'm the student.
I was saying, since we're going to divide it by this, why do we have to times it by this?
If you times it by this, right, you have EV.
In joules.
If you convert from joules, right, we convert from joule, what are you going to have? EV. You divide by E, E cancel
I'm
E.
looking at that part. I mean, here, when you are solving, they gave us the work function in principle. Why did you have to bring in this thing? I know, but I just want to ask again.
Okay, you converted this. You know work function, the unit for work function is in joules. If you should solve this now, you may not see the answer in the option if you do not add, if you do not convert it. So they expect you to know some of these things.
Because even when we just solve it without converting, it didn't give us this answer.
Okay, you
So
understand?
that's what I'm asking.
So there's a need for that conversion. Please be looking at what she's doing. What she's doing is correct. You that want to copy, be copying. Not when I want to wipe, they say no, sir. So we need to review this marker for us. Is there any challenge? You need to help us review this marker.
Yeah, solving because
Stop here.
she's solving
What are these answers?
Stop here and explain.
and
Explain it for them.
Now for
Listen! Listen! You want to explain?
number 2, we are to find finest energy. And formula we are going to use EK equals to E minus W naught. That is
Let them repeat the marker.
That's the work function.
You can pass through the back door.
Because our E is 3.96, we are going to minus it. Then minus it to the work function. That is 1.90. And we know that we have to get our 1 EV. The normal value for it is 1.6 exponential minus 19. And since this is in joules, this one also supposed to be in joules for us to subtract. So now then we now multiply 1.90 times 1.6 exponential minus 19. And the answer is 3.04 exponential minus 19. Then we subtract it. Then our answer is 9.2 exponential minus 19.
Can you put your hands together for her?
Then
You want to solve number 3?
no, I don't think
And don't worry, that one you are going to number 3 already. Is that okay? Let them bring the marker. Can you put your hands together for her again? Do you understand what she did? Do you understand what she did? Hello? Hello? Do you understand what she did? Ajia, what's the name? Do you understand what she did? Eh? Which of them? Okay. You know about EV, right? Okay. And you know that 1 EV is equal to 1.6 exponential kaza kaza. Now, you know the unit of energy is what? Is what? Is joules, right? If you want to convert any value to joules, you must multiply. You understand now? You say 3.96. Okay, the one you saw was 3.97. Now, after solving everything, you know, even if you approximate this, it's stupid. If you approximate it, if there's another value at the front, right, it still be 3.97. Now, after using your 3.97 and solve, are you having the same answer as this? So your 3.97 minus this, what are you getting? Any question? There's anybody that don't understand? Okay. Yes. Multiply, not add. Yes. 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 Joules. Yes. They are having EV and you want to convert that value of EV to joules. You multiply by 1.6 exponential minus 19.
Like depends on what they have option.
Yes, still depends on what you're having in the option. If they give you in EV, glory to God, okay. If they give you in joules, so you know what to do. Please. We're on the saver side. 9.7. After subtracting, you subtract 3.0 exponential 19 from 3.997 that you say exponential 19. Exponential 19. You did this. How do we got this 3.96? Is it from the question? Is it from the question? It's from the number 1. That is number 1. You need to calculate it again. Maybe there's a challenge there in the calculation. Is that okay? Have you filled it? Can we move forward?
Yes, sir.
Ask a question. Ask one question. From beginning of photoelectric to the end. Add one question because I'm about going to the next topic. So that I will not do reverse. Okay, the third, number 3. Hello? Hello? Number 2, they say we should find what? VS. Stopping potential. And it's equal to what? HF minus work function all over E. And also equals to EK all over E. Right? We have our EK to be what? What? We have our EK to be 9.2 exponential minus 20. Convert it to EV. How do you convert to EV? You divide by what? Right? When you divide, any answer you are going to have, it will give you what? Whether 2.00 EV. I don't know the answer you are having in your own after doing this. Right? Then the answer you are having is EV all over E. You can easily cancel out E and tell us that the answer is 2V. Are we together?
So the answer is 0.575.
Now, this is in joules, right? I want to follow shortcuts. I want to ask a question. Yeah? Okay. So this is 20. Thank you. This is in joules, right? And then we are looking for the stopping potential that will stop that electron from moving to the other side, or that will stop it from movement. That's what we are looking for. Then we say kinetic energy, the unit is in joules, right? For you to convert from joules to EV, you need to divide by this. 1 EV is equal to 1.6 exponential minus 19. So when you divide this, what's the answer? What did he say is the answer? 0.575 EV. Now, your EK is now equal to 0.575 EV. So you bring it here and write. You say 0.575 EV all over E. E will cancel E. You have 0.575. Is that okay? Can we now move forward? Can we now move forward?
Leave the last one.
I did leave the last one. Yes, sir. God not like to be confused. You that are supposed to be explaining to the people, I've been on to the people. You are getting confused. I know you are a student, of course. Even me, I'm a student too.
I understood that you know you got 2 EV, then like you got 2 EV over V.
Where? Where? I was just using instance too. Hey, Toby. This is your confusion, eh? Hey, Toby. He said, I got 2 EV. I was just setting an instance that after dividing, you may be having 2 EV. Then you say E cancel E, you have 2V. Then I've not gotten the answer for this.
Where's that 1.9?
Which of them?
Second one. I don't mind that one was from when you block
So I can ask.
You can ask your question.
I want to object something.
Okay. Objection. So that's the objection of a rule.
that one. The same thing.
Please continue. Let me.
I'm going to the next topic. Let's trash anything we are trashing here. Then we'll go to the next topic. You're having challenge with number 1, right?
What they did, they turned the one for the constant of E, the one with the minus 1.
Converting that EV. That work function, the energy is in joules. Work function has to be in joules for you to get an accurate value of whatever thing you are looking for. You use it direct.
That one
from the work function.
Yes. So now I'm just seeing it now. If it's going to 1.9, that should be 1.9E.
Yes.
And that is like a variable. I can't just
Thank you very much for understanding. Any question? Any question?